Hello and welcome to IPC Global Channel. My name is Igor Alcantara and today we're going to talk about hypothesis tests in Qlik. A hypothesis test is when you have two numbers you want to compare and you want to see if those numbers are different statistically speaking. There are multiple types of hypothesis tests, but in this video we're going to cover one of them. It's what we call the t-test or the student test. So when you have a small amount of data or when you have a sample and you don't know the parameters of the population, specifically the average and the standard deviation, or when your distribution is not normal, meaning you have more values below the average or above the average than closer to the average. When those scenarios occur, then we use a t-test. And this is the formula for a t-test. So we're taking the average that you're analyzing, subtract by the average of the group you're comparing to, and then you divide it by the standard deviation divided by the square root of the number of elements. It seems complicated, but it's very easy formula to apply. In Qlik, we have the TDIST function that require three parameters. The value itself that you're analyzing, which is this formula, something we call degrees of freedom, which is basically the number of elements minus 1. And I'm not going to explain on this video why degrees of freedom is number of elements minus 1, but it's basically how many positions you can move one number in the list of the other numbers. And then we have the third parameter, which is called tails, that has two possible values, one tail or two tails. When you have one tail, it means we're comparing if the values are either greater or less than the values. Meaning, if we're comparing the virus count as our metric of success, if the number of tails is 2, we're not saying the virus count should be greater or equal. Could be any one of those. But when you say the number of tails is 1, you're taking one of those specifically. So you're saying then difference must be positive or negative, not both at the same time. Let's see this in action. Go to this sheet, click down editing, and let's see how this works. The average product price for single customers is $503.40. The average price of products purchased by married customers is lower than that, $440.70. So my hypothesis is that single customers buy more expensive products in average than married customers. Because I can see there is a difference where single customers in average are purchasing more expensive products. But the question is this difference significant or is due to chance? So my null hypothesis is that difference is not significant. It is too small for us to make that claim. The alternative hypothesis is that the average is big enough that we can then reject the null hypothesis. Let's take a look at the histogram of the price for all of the customers. Then we can see that most of the products are in the bucket from $0 to $200. Where we have some very expensive products that move both average up. Remember, this is the formula to calculate the t-value in the t-test. Let's then calculate the p-number. I do have already a KPI with that calculated. And the p-number, it's so small that we need many decimal places to see the number. And I place a condition here where if the p-value is less than 0.05, then I'll color green, and is way less than that. So that means the difference is significant enough so we can make that claim. We have good evidence for that claim. It means that this is the probability that this difference is because of random effects, not because of the marital status. Now let's see how this is calculated in Qlik. Let's take a look at the properties of this. Remember, this is the formula and this is how we are applying the formula. First, I have the TDIST function. And the TDIST function, if you remember, requires three parameters. The t value, which is all of this part that I highlighted. The second parameter is degrees of freedom, which is the number of elements minus 1. And the third parameter is tails. My hypothesis is single customers buy more expensive products than married customers. So that's why I have tails equals to 1. I want to analyze just one direction, which is more expensive, which is the difference is higher. If my statement was single customers purchase product in a different price average than married customer, when I said difference, I'm not saying that it's more expensive or less expensive. So then this number should be 2 tails. Now let's take a look at how we calculate the t value. We're basically applying this formula. First, we're going to take the difference. That's the top portion of the formula. So we're taking the difference. The difference is the average price for single customers. So this set analysis takes the average price for single customers only. And we subtract that to the average price of married customers. So that's the set analysis married status equals M. But I don't care if this is higher or this is higher at this point. So then I take only the absolute value of the difference. So that's why I'm using the FABS function, the function absolute in Qlik. Now let's go to the second piece of the formula. So it's divided by the standard deviation divided by the square root of the number of items. So the standard deviation is calculated by stdev function. If you don't know how to calculate standard deviation in Qlik, then check our channel for the descriptive statistics video. And then that is divided by the square root of the quantity of the group that we're comparing against, our control group, which is the married customers. So that seems complex, but after you break down, it's not that much formula. It's how we calculate the p-value using a t-statistics. If you have a different type of tests, you can also use Qlik. Qlik is capable of doing a z-test for normal distributions, an f-test, a chi-square test, and all the different specific types of t-tests. I hope you liked this video. Don't forget to comment, subscribe, and share with your friends. See you next time.